Okay, 6.1 radian measure. So radian measure. Radians are another unit which to measure angles of rotation. So up until now, we've always measured in degrees. Okay, now we're going to measure in radians. And radians are measured and converted with pi. Okay, which of course pi we only use with circles. Okay, radian measures the size of an angle in terms of the length of the arc that subtends the angle at the center of the circle and the radius of the same circle. So that's the definition. Go over that again. What this means is, so when we talk about the length of the arc, we're talking about arc length. Okay, so we have some angle here in radians. By the way, I want to highlight this, make a note, must be in radians. You cannot complete arc length questions in degrees. Okay, so the measure of the size of this angle in terms of the arc length. So arc length is the length basically around the arc of the circle. Okay, and the formula for that is theta equals arc length, which we denote as an S, over radius. If you put arc length as an A, that's okay too. Okay. All right, we're going to touch on the unit circle. So radian measures of angles come from the unit circle, i.e., a circle with radius 1. Okay, so when we talk about a unit, this means 1 unit. Okay, so this circle with radius 1, as an example, this would be the point 1, 0. This would be the point 0, 1. This would be the point -1, 0, and this would be the point 0, -1. Okay, so we would have those around it. Okay, using the concept and the definition of a radian measure, it can be shown that 1 radian is the measure of the angle that creates an arc the same length as the radius. Okay, so again, this adds to the definition here. So if we have some angle theta, if we have 1 and 1, and then our arc length of 1, we're going to have our theta equal 1. So 1 radians. Okay, and 1 full circle is 2 radians. Or sorry, 2 pi radians. Okay, so when we actually look at like 1 or like 1 rad, we put it rad. Okay, I want to point this out to you, 2 pi. So pi is the number, I'll put this in red, 3.14. Okay, that means pi by 2 would be 3.14 divided by 2. That would be 1.57. So it would be clear that this angle, this radian measure, is 1 radian. Okay, 2 pi would be 2 times 3.14, and that would be 6.28. And 3 pi by 2 would be 4.71. So overall, instead of using degrees from last year, which are 0, 90, 180, 270, and 360, we're now going to be using radian measurement, okay, expressed as 0, pi by 2, pi, 3 pi by 2, and 2 pi. Okay. If we have approximate numbers, that's going to be 0, 1.57, 3.14, 4.71, and 6.28. Okay, and we're going to be learning how to work with this radian measurement. Okay, so I'm going to point this out. Note, since the circumference of an entire circle is 2 pi r, right? So circumference is 2 pi r. If you guys remember this formula from forever and ever, we usually write in like 2 times 3.14 times whatever our radius is. This is actually the circumference of a full circle. So when we're talking about arc length, we're kind of talking about whatever, like for example, whatever the radius is, and then we would like divide it or like find the proportion of how much of the arc length that we want, okay? So going back to this, the measurements of arc lengths often have pi in them. That's very normal. Leave them as pi. Okay, we're not going to convert those. So often, but not always, radian measures have a pi in them too. Okay, and then this is like written in exact form. So for that reason, 0 degrees is the same as 0 radians, and 360 degrees is the same as 2 pi radians. And we kind of already saw that right here, right? So we saw like this connection. So again, in other words, 180 degrees is pi radians, which is right here. So the first thing we're going to do is we're going to learn how to toggle back and forth between radians and degrees and between degrees and radians, okay? So back and forth. So when going from radians to degrees, we want to multiply by 180 over pi. And going from degrees to radians, we want to multiply by pi by 180. If you think about this as a conversion tool, 180 degrees equals pi radians. So this is actually kind of multiplying by 1. It's just making it look differently. Okay, example 1. Convert the following radian measure to degree measure. So radian to degrees, we're going to multiply by 180 over pi. So how we do this is if we have pi by 6, we're going to multiply by 180 over pi. Okay, these pi's cancel out. There's a pi in the numerator and pi in the denominator. We're left with 180 over 6, which cancels to 30 degrees. B, 7 pi by 4, okay, times 180 over pi. So those pi's go away, and we have 7 times 180, and we get 1260. And then we divide that by 4, so we get 315 degrees. And C, negative 3 pi, we want to do times 180 over pi. The pi's go away, and we get negative 540 degrees. Example 2, convert the following degree measure to radian measure in exact form. Okay, so we're going from degrees to radians. So we're going to multiply by pi by 180. So 30 degrees, we want to do times pi by 180. Okay, so the pi, let's just bring it down. It's going to be in the numerator. Okay, it's not going to go anywhere. And we essentially get like 30 over 180. But if you put that into a fraction, we know the zeros cancel, and 3 over 18 is going to be 1 pi over 6. We can also write just pi by 6. Okay, and when we write over, we pronounce it by, so pi by 6. 45 degrees, we want to multiply that by pi by 180. Okay, so it's essentially 45 pi by 180. So if we put 45 ABC 180 into our calculators, we're going to get 1 over 4. Okay, so this here cancels to 1 over 4. So we can say pi by 4. Just carry that pi down. Again, do all of this work in your calculator without the pi, and then just put the pi back in at the end. Okay, and 210 times pi by 180, of course, that's going to be 210 pi by 180. But if you put 210 over 180 in your calculator, it is going to be 7 pi by 6. Example 3, find the value of the variable in each of the following diagrams. Okay, so when you get a diagram like this, we're seeing a circle, we're seeing an A for arc length, or S, doesn't matter. And then we see an angle. And obviously 2 is going to be a radian measurement. Okay, 2 is not going to be in degrees. You can only calculate arc length or work with this formula when the question is in radian measurement. Okay, so we're trying to find the arc length here. So our original equation is theta equals arc length over radius. Okay, let's sub in theta is going to be 2, right? 2 radians. Arc length is going to be A, and the radius is going to be 6. All we have to do is cross multiply. 2 times 6 equals the arc length. The arc length is 12 centimeters. Okay. For the second one, we have an arc length here of 45 centimeters. And we know that it's this entire arc length and not this one in here because of the angle that is identified. Okay, this entire thing is the angle. So this is almost going to be 2 pi, right? If you think about it, like, well, as per the diagram. Okay, and then we have a radius of 10. So theta equals S over R. So our theta we don't know. S is the arc length, that's 45. And then 10 is the radius. So we get theta equals 4.5, and that's measured in radians. Okay, so not as actually accurate as the picture, but that's okay. And then the third one. So we have an arc length of 28, and we have a theta of 3.2. So we're looking for the radius. This is a little bit more math here, just a little bit. So theta is 3.2. We have an arc length of 28, and we have a radius of r. We're going to bring the r up, and we're going to bring the 3.2 down. Okay, or this cross multiplication. We don't have to cross this 1, but we can move the r up, 3.2 down. So we get 28 divided by 3.2, which is 8.75. Okay, that's the radius there. Example 4, a Ferris wheel has a radius of 15.4. Okay, so here's the Ferris wheel, here's the radius, it's 15.4 meters. How far does a rider travel if they make 3 complete rotations in their Ferris wheel car? This is simply like circumference of a circle, okay? So in one full rotation, we're not talking about the angle, like the angle would be 2 pi, right? So we're not talking about the angle, we're talking about how far. This is going to be measured in meters. So circumference equals 2 pi r. So 2 times, let's leave it as pi, and the radius is 15.4. Okay, so this is 30.8 pi. And that's in one rotation. Okay, so now in 3 rotations, we have 30.8 pi times 3. So 92.4 pi meters. Okay, and you can write a therefore statement. Therefore, the rider travels 92.4 pi meters in 3 rotations. Example 5, radians are used to measure angular velocity. Okay, angular velocity allows us to determine how quickly an object rotates in a circular motion, and it's measured in radians per second. So here's the question. If a motor turns at 1,200 revolutions per minute, what is the angular velocity? Okay, so first of all, we have 1,200 revolutions per 1 minute. What we want to do is we want to multiply that by a fraction that is going to allow us to cancel out the 1 minute in the numerator and the denominator. So this and this we want to cancel. So we have to find an equivalence. 1 minute is 60 seconds. So this leaves us with 1,200 revolutions per every 60 seconds. Okay, so simply 1,200 rev divided by 60 is 20 revs per second. okay? But this is not in radians per second, so now we have to convert to radians. Okay, I'm going to transfer this 20 rev per second down here. So we have 20 rev per second, okay, per 1 second. Okay, the 1 second is good. We want that in there. So what we want to do is we want to find a number to multiply this by, an equivalence to multiply this by to get rid of the revolution. So when we think of one revolution of a circle is one full circle. It's 2 pi radian. So 2 pi radian is one revolution. This is just like when we're finding a common denominator, we're multiplying by 1, right? Like 1, okay? Because these are equivalent. 2 pi radian, 1 revolution. So these revs cancel out, and we're going to have 20 times 2 pi over 1 second. So this gives us 40 pi per second. So therefore, the angular velocity is 40 pi per second.